Thank you for having me. And I wanted to run through this presentation about things to keep in mind as we as an industry work on self-sovereign ID solutions during COVID-19. There's a big sort of call to action that's happened as we all try to apply a technology solution to this problem. And undoubtedly, there's a lot of things that we can help out in doing things properly. So what I wanted to do is to run through with my experience of like taking things from an innovation lab to production scale rollouts. So if you go to next slide, just keeping in mind that while many companies are working on solutions for COVID-19 right now, next slide, keep in mind these obvious greatest hits of bad ideas, because the first is storing any kind of personally identifiable information on distributed ledgers. I do keep on seeing this crop again and again at times. This is regardless of whether you're looking at permissioned or public blockchains. And part of this includes looking at, yes, if you're keeping any linkages that use pseudonymous or anonymous IDs, as you call them, they may not necessarily be pseudonymous or anonymous. A great example of this is there have been proven cases where people have been able to reverse engineer someone's Netflix profile or what searches a specific person had done based on anonymized data. So what do you think is anonymous is not necessarily anonymous. And this also applies specifically in the self-sovereign ID space if you're looking at decentralized IDs. So when you're looking at where your DIDs in decentralized IDs are stored, keep in mind that if it is on any kind of ledger, it can be personally identifiable information. Thirdly, keep in mind SSI doesn't specifically need distributed ledgers. So I know the two quite often get combined together, and there's a reason why the term is called decentralized identity. But within decentralized identity itself, there's many ways of delivering it, some of which don't necessarily need distributed ledgers. So think about your specific use case and look at what exactly are you storing on a distributed ledger in the first place. Because in some cases, what you might have to do as an interim solution is to use centralized databases while still achieving self-sovereign ID. So keep in mind what the technical implementation of that is like. Next slide, please. But most of the action that happens within these COVID-19 use cases, or what I think in most use cases, is how the data is stored and shared. So when we think of the self-sovereign ID ecosystem, the two big standards get spoken about are decentralized IDs, verifiable presentations, and verifiable credentials. A large part of like the action or the actual knowledge that is being shifted from one place to another is going to be on verifiable credentials. Here, I have seen quite a bit of philosophical debate happening about whether it uses zero knowledge proofs or not, whether there's certain kinds of representations within verifiable credentials that are used. So if you could move on to the next slide, keep in mind that there are already a lot of standards for electronic health records that exist. One record especially to look out for if you're building web-based applications is a standard called FHIR, pronounced as FHIR. So think of how you can adapt to the existing healthcare records, and don't try to create verifiable credentials necessarily or what fields you're storing from scratch. Lean into the existing knowledge that is already there. This is for a second reason. You might store some information in a verifiable credential in your own proprietary format. That's fine. But when you have a presentation which needs to be actually used by doctors or any medical systems they use, you might regardless need to interface with these systems, which might talk a standard like FHIR anyway. And that's where you get to standards proliferation if you try to reinvent the wheel. So if you move on to the next slide, I think this is a call to action within the industry, yes, for creating solutions that can support our frontline staff, but also to remember that there's a responsibility here to first do no harm. It's the same kind of pledge that doctors need to take, and I think it's an important one that the technology industry working on these solutions needs to take as well, because there are very severe implications to rolling out a half-baked solution, especially during these times and especially on a tight schedule. So if you can move on to the next slide. Think of how you manage and generate keys. This is going to be important for a couple of reasons. So if you move on to the next slide, the first is security. Think very closely of any sort of solutions that you've been building so far, and this is just sort of like a sense check. I'm sure some of you know about this already, but this is a good point to take a sense check if you're rolling out solutions for COVID-19 to say, the software libraries that you've created, have they got vulnerabilities against them? If yes, there are scanning tools that will help you scan them out. One is called the Open Web Application Standards Project Z-Attack Proxy. That can help you test in runtime if you have vulnerabilities, or if you're running on GitHub, GitHub can automatically scan all of your repositories for you and tell if you have any security problems. If you're hosting this in the cloud, are you generating keys using cloud-native tools? Are your keys entirely on the edge device? And if yes, how are you securing them? And think about recovery. Think about how you can do any sort of like backup. This is more from the consumer side. Think of like, how you can back up the verifiable credentials of the keys. Are you using existing things like iCloud Keychain, Google Drive? Are you doing anything like seed words? Are you doing two-factor recovery? And also think of delegated access, because especially in situations like healthcare, you need to have things like, what if somebody is not able to actually reach their phone and consent to some release of information? Or if somebody is a parent and they're managing healthcare information on behalf of someone else, or if somebody is a vulnerable or elderly person who doesn't know how to operate that technology. So think about those issues. If you could go on to the next slide. Think also of how this has happened in the past, where there have been vulnerabilities that have been detected. One key thing to look out for is a lot of self-sovereign ID solutions have some sort of app and some sort of backend. And if you're relying on the blockchain or the security mostly on the backend, bear in mind that that itself could be exploitable. So think about that security between your client application and your backend. If you move on to the next slide, another big thing that I personally know from projects working with the NHS and a lot of government agencies is there are scenarios that you need to account for in terms of failure. This is not the time to code for happy parts. So if you move on to the next slide, think about what happens to your app in case of like disconnection from the internet. Especially working with NHS and in healthcare scenarios, this is a problem that you will encounter in hospitals where you don't have good connectivity. So how does your application maintain state? What if it loses connection in the middle of doing something? Can it keep that? Can it actually recover from that gracefully? And one example that I want to highlight here is Facebook used to do something called 2G Tuesdays, where the entire Facebook campus, if the particular developers had opted in, their internet speeds would be reduced to like a 2G-like quality. And that was to teach the developers, this is how most of the rest of the world experience and browses the internet like. So there are tools that will help you simulate bad internet connectivity at them. And I'd say throw it at your self-sovereign ID solutions and see how it actually behaves, and not just in theory. If you move on to the next slide, then test your failure scenarios again. Now looking at less from a technical side, but like, sorry, if you could go back one slide, which is what happens in human error. And the one example that I want to give here is there was a nuclear sort of like missile test in Hawaii that got sent out because of bad interface. And that's a screenshot of the actual bad interface they were supposed to figure out using one of these blue links, which was the actual drill. So go to this link called baymart.com. They're a really good UX research agency that can tell you how to account for a lot of error states like this. That's it from me. That's my experience working with NHS. And this is more from not from the rules and framework side, but how do you actually roll out solutions? And I'm happy to answer any questions.